build a self-correcting SQL agent to chat with relational databases. Here we have a React Reason and Act code agent which has access to SQL tools and an LLM engine. We invoke the agent with a query. It got it wrong the first time, then the agent corrected itself, and in the next step it gave the correct answer without any human intervention or human in the loop. Let's see how to build it using HuggingFace. Alright, we first need a SQL database. So let's set up a very simple in-memory database using SQL Alchemy. Okay, a bunch of imports to create the database. We are creating this in-memory database and we have a table called receipts with only 4 columns: receipt ID, the customer name, price, and the tip. We have inserted 4 records. This is how it looks like. All right, and then our agent slash tools, they need to know the schema of our database. So we are using this inspect method just to create this. Okay, since we have only one table, we have these 4 columns. Okay, all right. Now comes the interesting part. So to create a tool using HuggingFace transformer agents, we need these 5 inputs. Okay, so we are creating a tool here, which is a class. We give it a name. The description is the most important one. It allows the agent, because typically we give multiple tools to an agent. Now agent uses the description of the tool to determine which tool to use. Okay, so here we give it a description of what this tool does. And more importantly, it also includes this table description because it needs to know the schema of our database to generate the right SQL code. Okay, and then we have the input in the form of query, which is the text. To this also we can give some description. The output, that's the 4th variable. All right, and most importantly, every tool in HuggingFace framework should have a function called forward. Okay, this is the function which is executed when this tool is invoked. Okay, so in this case, it simply takes this query, connect to the database, execute the query, and return the output. Okay, that's the most important part. Creating tools is the most important part. Now creating agents is super easy. All right, now every agent require at least 2 things: tools and an LLM engine. So if we want to use open source LLMs hosted on HuggingFace, we can create an account and get the token and just log into HuggingFace. All right. Now to create an agent, there are 2 types of agents in HuggingFace. One is this React code agent. The other one is more general purpose React JSON agent, right? And then since we are going to use the LLMs from HuggingFace, we also import HuggingFace engine. All right. So create an agent. Now agents are typically used for solving complex problems. So we need more powerful LLMs. Okay, so currently the most powerful LLM on HuggingFace is this Llama 3.1 or Llama 3 70 billion parameter model. Most of the LLMs on HuggingFace are for free, but since they need the instances up and running, not all of them are free, especially the powerful ones. Okay, so we are using this less powerful, a smaller Mistral 8 billion parameter LLM. Okay, all right, so we define the agent and then we simply invoke the agent. So it's a very basic query, name of the client who got the most expensive receipt. All right, so this is the right answer. If we go back to our data, yeah, it's this Woodrow Wilson, $53+ bill plus $5 plus a tip. That's looking good. Now, if we want to leverage the LLMs from, let's say, OpenAI or Anthropic, Mistral, etc., we can do that. For that, we need to create an engine first. Okay. Now this code is provided by the HuggingFace, so we don't need to make any changes to it. Here we are simply defining an engine, okay, an LLM engine. All right, we can give a default model to use, and obviously we need the API key as well. So you don't need to make any changes to this function. All right, now let's see how we use this. So this time, instead of HuggingFace engine, we are using OpenAI engine. Okay, now with model GPT-4o mini. All right, the same question. It's super simple, so the agent got it correct. Now let's make it a little difficult. It is still easy, but a little difficult. Now this time, we are going to create a new table called waiters, which simply has the receipt ID with the waiter name. Okay. Now these 2 tables, the previous receipt table and the waiters table, we can join them via the receipt ID. All right. So we created this table. We inserted some records. Now we need to update the schema of the tool, correct? So what we are doing is, again, we use this inspect element to create this schema. So we have two tables. One is the receipts as before with these 4 variables, and the types. We have created a new table called waiters with these 2 new columns. Okay, so we have updated description. Now we need to update the tool also. So that's what we are doing here. So SQL tool description is equal to updated description. We have updated the description of our tool. Now, as before, we just create an agent. We are still using GPT-4o mini. Now let's ask this question. So this question, which is which waiter got more total money from tips? This requires joining the 2 tables. Let's see what happened here. So initially, the agent assumed we have a column called tip within the waiters table itself and came up with this query. Okay, but we don't have the tip information within this waiters table, right? So it got failed. Then the agent corrected itself and it realized it need both the tables. So using the join, it connected the receipts table with the waiter table and created the right query to come up with the right answer. Okay. Now let's see what happens if we use more powerful LLM instead of GPT-4o mini. Okay. So we are doing exactly the same thing, but this time it's GPT-4o, not mini, right? So when we run, we got it correct the first time itself. Okay. So here is the answer. Michael Watts. That's the right answer. Now you can imagine, even with powerful LLMs, when we have more complex use cases, even these powerful LLM/agent might not get the answer right the first time itself, right? So in such a cases, instead of using the LLMs, if we use these self-correcting agents, then the chances are that the agents able to complete the task correctly. I'm going to create more agent videos using HuggingFace. Thank you very much.